This is your VMware, Visual Studio Code. It will keep prompting you, do you want me to install this, install that? Actually, the best way to open this would be not straight away. Like, let's say this is our home, right? Normally we create a folder in this where we'll be keeping all our files. This is where we'll be writing all our, let's say, Python scripts. So from terminal, come to this folder. Here you say code dot, which means code is the shortcut to open Visual Studio Code. I'm saying open code in the current directory. Dot represents the current directory, right? So I'm saying open code in the current directory. It'll directly open your Visual Studio Code and take you to scripts directory. Right? This is a safety mechanism which keeps saying, okay, if there was any code, do you trust the authors of this code? Say yes, and that's it. You are ready to go. You're ready to start creating your first .file. Yeah, so the moment I said py, right, it's saying, do you want me to install extension for Python? Say yes, this will be useful. Let me open the session. Password is DevNet student, all small, no spaces.
Recording in progress.
While that is going on, let me repeat the steps for the benefit of, for the sake of recording. Open the terminal, you will be in your home directory. I normally work this way. I create a work directory. Inside that, I'll create a scripts directory, which is where I'll be placing all my scripts, the code that I'll be writing. So come here. From here, we'll open code directly from command prompt instead of directly opening it from here, because this is where I'll be placing all my code. I'd say code dot. It says that code is the shortcut name, right? Executable name for Visual Studio Code, and dot means current directory. Open code in the current directory. It opens up, and you can create your first Python file with the .py extension. The moment you create a file with this .py extension, even before you start writing your code, this guy will start prompting you. Right here, it is detected that there is Docker installed on my system, and it's saying, do you want to install? Right, we'll not be getting into Docker. It's a little advanced thing, but yes, let me go ahead, and that is going on. The moment it detected the Python file is being created, it prompted, do you want me to install Python? I said yes. It installed. As a result of which, I get this. Before installing that plugin, I did not have this option. Now I get this. This will help me to execute this file without going out to my terminal. Right now, I don't have to go back to my terminal anymore. I can write code here, execute here. You simply click this, your Python is invoked and your script is invoked, and you see the result. The other way is you manually open the terminal. Delete this terminal, go here and say new terminal. You are here and your scripts are here. You simply say Python. Because Python is set in path, you can simply say Python. And the script, your script name, first one Python. Okay, for now, this is good enough for you to start working with it. The other things I'll explain shortly, like next week, we'll be starting something called Ansible. So I'll tell you on Monday, like how we can access Ansible and so on. This is Postman, which is used for APIs. So when we come to that, I'll explain. Git installed. Yes, it is there. Yes, it is there. Everything is there, which is required for you. Yeah, that's it. Okay, now you can take the guide. Recording sessions, recording of the sessions I've shared with the team. They're just doing some basic editing, and then they'll be uploading it to the portal. So you should get probably by tomorrow or over the weekend. Any questions with this, your lab environment? I mean, these are all very simple tools. You can set it up, but I mean, if you take this, it's like you can save a lot of hassle. Right? Sometimes installations go wrong, paths are not set properly. Yes. So for Ansible, it would be required. Because Ansible can be installed only on Linux machines. If you have Ubuntu installed on laptop, you don't need it. Yes, but then you'll have to install Python, Ansible, Git. If you have those three, then you're good. Okay. Okay, there are some restrictions on this. It will not let you do some things, but whatever is already there, it's good enough for you to get started off. Power off. Ansible supports Mac OS. Yes, it does. You can install on Mac OS as well because it's basically a Linux kind of kernel. It has the Linux kernel underneath. Do you want to install Ansible on Mac? Yeah, git Ansible Postman. Okay, let's get back to this question. Anyone has any questions on the topics that we have covered so far, especially functions or loops or conditionals, anything for that matter? Postman is also there. Docker is there, but we'll not be using it. Right? Docker is until advanced concept. We'll not be using it much. Postman is more important. It will help you to integrate different things via APIs. Okay, yesterday we got started off with Python modules, and some of you wanted it to be revised again, right? Basically, modules are like they will help you to extend the functionality of Python. Some Python comes with certain functionality, and some additional functionality is available in the form of modules, which you can download, install, and then use it. Now, there are some modules which come pre-installed with Python. Yes, you'll be getting all the previous session recordings. Okay. How do I explain modules are? Basically, it's like, as we know, Python can be used for many other things, right? It can be used in data science applications. It can be used in artificial intelligence, machine learning, to build web applications, to build network applications, right? Now, in artificial intelligence or machine learning, let's say there is certain functionality that you use, some specific tools that you'll be needing, right? Those things, if Python has to come with everything which supports AI, ML, networking, UI applications, scientific computing, etc., it's going to be like a mini OS, right, in few GBs, right? So that's why instead of doing that, if you see Python as it's about 28 MB or something like that, it's pretty lightweight. So they ship core functionality, which is required for you to start writing basic programs. Then rest all, if you intend to use Python for AI/ML, you can check what are the libraries which are available for that, and you can download them. If you plan to use Python for network automation, we'll check like what are the packages, which libraries which are available. We'll be using them, as is our case. So that is the concept of Python modules, right? They have given certain core functionality, and they have given rest of the functionality in the form of third-party libraries. And these libraries are nothing but collection of packages. These packages are nothing but collection of modules. Modules are nothing but Python files, right? We call them as libraries, right? If you want to draw an analogy, what is a library according to us? Where we have a huge number of books and journals, right? Which is a place, which means there are so many authors who have done a lot of research. They have put all their research and knowledge into in the form of books, so that we can just go borrow their knowledge by borrowing the books from the library. Same concept, right? Library is a collection of packages. So some guys who had some problems at their hand, they solved those problems, wrote Python code for that, and they wanted to give it back to the open source community. So they made all their hard work available in the form of third-party libraries, which are nothing but a collection of packages. Packages are nothing but a special kind of folders, right? And these packages consist of modules, which are nothing but Python files. Okay, so if that is the case, if modules are nothing but Python files, Even I'm writing so many Python files, right? Till now we have written 17 or 18 and odd Python files. Those files also can be classified as modules. Yes, they can be, right? Any Python file that you write becomes a module and can be reused somewhere else, right? So typically, when you are writing modules, what you do is you can create a module to define data, right? You have a lot of data like the connection parameters of different devices, list of devices, configuration settings to be done on different devices. All this is data in your case, right? All that data you can dump into the corresponding data structures and put it in one Python file. You create a library to define your device and then create a list of these devices. All that data will be in this module, which you use for defining the data. Then you can create another module for utility functions, which means some useful functions that you'll write, right? There will be some things which you do again and again. For example, reading from a file, reading some data from a CSV file and processing it and extracting some details out of it. For this, you can write some utility functions and provide them in a module. Or after the data comes back from the device, extracting some values from it and then writing it to a file. All such useful functions which you will be using again and again can be put into one module. We can call that as util module or utility functions, which consists of utility functions, right? So you can write one module for data, one module for utility. If you have very small amount of data and a few utility functions, you can combine both of them into a single module, right? A single module which contains your data and util functions. Then you will start writing your actual Python code, Python program, which borrows these modules which we have defined above. And uses the data or the util functions defined in the module. Okay. That's how modules work. Now, some modules, I list some modules that will be using them, right? We have different types of file formats. Most common are CSV, JSON, YAML, YML. Right? We'll be coming across mostly these three files. CSV, which stands for comma separated values, which looks like Excel. You can open CSV files in Excel, but they're not actually Excel files, they're just text files. JSON stands for JavaScript object notation, which looks like this key value pairs, like Python dictionary. We have seen the dictionary in Python, right? JSON files look exactly like Python dictionaries. YAML is another format which has become very popular nowadays for writing configuration files, right? We are going to see in the next section in Ansible, we'll be writing some things called as playbooks in YAML language structure. Right? So it makes sense for us to figure out how to work with these different types of files which are frequently used in our day-to-day jobs. So needless to say, to work with CSV files, you have a module called as CSV. So you'll say import CSV and do something. To work with JSON, you have a module called as JSON. So you'll say import JSON. Same way, import YAML, and then figure out how to read the data from these files, how to write the data back. And then you have import Paranico, which is automation of SSH. And then you have import NetNico, which is a advanced version of parameter specialized for network devices. Right. So these are the modules, and this is the way we will be importing them. Yesterday we had seen one small example. Right. This is the module which I have written. I have put in we were not able to call the module because I was referring to the variables incorrectly, which I have rectified. I'll be showing it now. So my module consists of two variables, right? Name and profession. The variables are called as my name and my profession, and then a simple function, right, which takes two strings and prints them in a special format, in certain specific format. You see, I'm not calling my method here. I've written another Python file which says which calls my module. So in this, I'm saying import my module. Right? Once my module is imported, whatever is defined in this my module are available here. So since my module is imported, I can say my module dot my name. Why I have to use this my module dot my name? Because my name is not here. My name is not defined here. It is defined inside my module. So I'll have to say my module dot my name, my module dot my profession, and to call that other function, my module dot display. Is it display? Yeah, it's display. What am I doing here? I'm making these parameters as default, so that in case I don't pass any values here, still I won't get any error. Okay. This my name, my profession are coming from my module. This function is also defined in my module, and it is coming from there. It's taking the default values which are specified, and it is showing some display, some this thing. Okay. Now, here my module is like very simple. There's just 2 bits of data and then one function. So it is okay. I can say import my module. But in real life, right, modules will be very big. They'll have a lot of functionality which is not really required. Right? You'll not be using all of it. Let's say some 90 or 95 100 functions are there. You'll be using 5 of them, and other 95 will be like will not be used. So it's not very efficient to import your entire module. In such case, what you will do is, let's say in this case, I'm not interested in the data which is defined, right? The user's data and profession. I'll not be using it. I'll be using only the function. So to use this function, if I say import module, all this which is present in this will come and sit here, will come and be available to this, which is not very efficient or which is not required. I want to borrow only this function. So what I'll say is, instead of import from my module, import display. Okay, instead of saying import my module, I'll say from my module, import only display. Then only display will come. Right? These things will, this will throw an error now. If I uncomment and run it, this will throw an error saying, I don't know what is my name, what is my profession, because we have not imported them. We have explicitly imported only display. Now, since I'm explicitly importing display, I don't need to use prefix it with the module name, right? From this module, I've explicitly imported display. So I can directly say display. Okay. So this is more efficient way of importing. Now there's a concept of packages. Package is nothing but package is nothing but a Python folder. A folder with a blank file. And your modules will be part of this. Okay. So this is nothing but a package. But then how do you use the package? Now this will throw an error saying there's no module named my module. So you'll have to say from my package dot my module import display, because now your module is part of the package. So you'll have to say from my package dot my module import display. Now there is any level of sub packages you can create, right? Let's say this is like your package Cisco, right? Within Cisco package, you'll have Cisco DNAC sub package, Cisco ACI sub package. So like that, related code can be separated into their own sub packages and accordingly given. So I can create new folder, find sub package, and move my module into a sub package. Now, how do I import this? From my package dot my sub package dot my module import display. Okay. Now, this is fine because you are writing your packages, you are placing them in the same folder, you are able to import them. But then, right, let me import something called as CSV. It doesn't give an error, which means it has found this CSV somewhere, it has imported. Where does it find it? Is there is something known as path, system path. Import OS, import sys, sys dot path. which is a list. So for path in system path. These are the folders where it tries to look for the packages which you are trying to import. You see the first location where it looks for is the current directory. I'm inside this CCDA DevNet. So this is where it tries to look for the presence of my packages, sub-packages, or modules. Right. So that's the first entry. If it does not find here, suppose this my package or this my module was not here, it will go to the second location, right, which is this inside Python 3.9 site packages, some folder. If it's not there also, then inside my lib, my installation, the zip file which came with installation is present. It will look in that. If not, there's an unzipped version of it, right? It will look there. If that is there, that is also not present, it will go to the lib dynamic load folder. If that is also not there, finally it will search in these, right? Virtual environments, etc., etc. So these are the kind of places. If let's say the module which I'm trying to import is not found in any of these locations, then it will throw an error and say, I do not know where your the thing that you are importing is located. So this is just for your information's sake. If you want to place your folders, right? This kind of thing, the site packages is a thing, or you can simply put them in your project directory itself as packages, so that you'll have a nice separation also, and they'll be easy to access also. Okay, any questions on modules? Okay. Module is nothing but any Python file that you write. Sys is not a third party this thing. Sys is built in, and you have things like OS. Sys OS package will has some useful utilities which will help you to carry on your shell commands, OS level commands. There's a very thin line between a normal folder and a Python package, right? Here I'll create a new folder. Package. I can place my module inside this also and borrow it from here and use it, right? But for some reasons, like let's say you want to ship it to someone, for shipping reasons, you want to denote this as this is not a normal folder, this is a Python package. So to make a normal folder into Python package, what you do is inside this, you create a blank file called as __init __.py. You won't be putting any content into it, just a blank file. But the presence of this will make this normal folder, convert this normal folder into Python package. How do you import variables from another module? Same way we have done, right? If you say import module, everything will come. Let's say you want to specifically like my name and my profession, you want to explicitly to import them. Okay, this is right. So I'll say from my package, my subpackage module, import display, comma, my name, comma, my profession. Okay. Now I'll be able to use them by code. Since I'm explicitly importing them, I can just use their name. I don't have to prefix it with any of this. These folders underscore PyCache, these automatically get created. The moment Python detects that these are packages and there's a file which is being called, these some internal folders automatically get. I have not created this because let me show you. Yeah, in this also it is since it is there. Once I place my module and import it, this PyCache will get there. Basically, it is like since it detects that since this module has been used, it does some caching mechanism. It uses some caching mechanism to detect that, okay, oh, looks like this this is a Python package which from which things will keep getting imported again and again. So let me cache it and keep it in my cache memory. Okay. So that's what I wanted to. Yeah, path is something. This is nothing like creating a lib. These packages are nothing but libraries. Right? You can just take this make this as a zip file. Of course, if you want to upload your code to Python package indexer from where other people can download it, there's a separate process which they have given the steps to be able to put it in certain format, to do some necessary testing. Only then you'll be able to upload your code to Python package index. Once it's uploaded to Python package index, we will call your code as library, which is available from the Python package index, which can be downloaded. Otherwise, there's nothing like a library. We call it's just a term used for this packages and modules, collection of packages. If you want to see Python package index, Wi-Fi. Right, there are close to 4.5 million projects. Sorry, this is 400,000 projects, 4.2 million releases, 7 million files, 600,000 users, and so on. Right. So NetMiko is coming from the Nornir. And latest release is this. Who are the contributors, which all versions it supports, etc. etc. Field Buyers is the creator and has made it available in MIT license. Just some facts. And the way to install it is pip install NetMiko. Pip is like a utility, right, which will help you to install different packages. Now pip knows where is this Python repository is located online, and from your command line you will directly give this pip install NetMiko. you won't tell where to go search for it, where to download it from. You don't have to do all that. It knows where all these are located. If you simply say pip install netnico, it will come here, download this guy netnico guy, and then install it. So as you said, like you want to create, so we can try downloading. So this is nothing but a tar ZZ. Let's download and see what is there in this. Yeah, so tar file. These are all, you see this a config file, a Python file, MD instructions. That's all. And this is your main netnico. And this, let's say Cisco. See, it's just a collection of Python files with underscore init underscore py. So each of these folders that we saw are packages. You go into any of this, you'll see the same pattern, underscore init py blank file and a module, right? So each of these are packages with modules inside that. Then all these packages are put together with some config file and setup file and some README markdown files with instructions. That's your library. If you are interested, you can even go into your Cisco's code and then see how the ios.py. Right? You'll see usage of object-oriented programming. Now they're treating this Cisco iOS base as a class, and then they're defining all these things. You see this Cisco iOS SSH, they decided, okay, we'll be writing something, but for now, I don't know what to write. So they just put pass. Okay, this is your underscore init function, which is your initializer. Anyway, this is just for extra information sake. Okay, that's your modules. Now that we know modules, we'll get into file input output. Right? As part of one of the very important aspects is we have learned how to interact with console, right? How to read the data from console using input function, how to write the data back to console using print function. But that's not the way things happen, right? You'll be getting the data from files. You'll have to store the data back to files. That's more useful, right? Rather than working with console. You cannot expect the user to come and give all the input at the console. So file operations become very, very crucial. And commonly used file formats are normal text files, CSV files, JSON files, YAML files, XML files, and so on. Right? So we'll see first how to, now all these files, right? All these types of files which I mentioned, CSV, JSON, YAML, these are all called as flat files. Flat files or these are just like text, normal text content. They contain text. Right? Why we call them as flat files? Because to differentiate with them with the other type of files like your Excel, doc, PDF, and these are not flat files because they are proprietary formats. And Excel files can only be opened with Excel, like Microsoft Office or Open Office, which understand this format. Same way doc, PDF can only be opened by like your Adobe PDF Reader, or there's a free PDF reader called as Sumatra, and there could be a few more. Right? So these are not flat files, whereas these are flat files, which means these files, whether it is CSV, JSON, YAML, I can open them with normal text editors. Right? I can right click and open with text editor, and I'll be able to see the data. Whereas if I open my Word file or PDF file with a normal text editor, I'll see some strange characters. So in that sense, we call them as flat files, or they contain just textual data in a slightly different notation, right? If you open a CSV file, you will see slightly different notation, JSON file, slightly different notation. And all these formats are interchangeable with each other. Let's create a sample this thing. CSV, which stands for comma separated values, looks like your rows and columns, like typical your Excel kind of system. Let's say device, type, device name, IP. Right. So first row will define columns, right? What is the data that we are talking about? These are known as columns. First column, I'll be putting device types. Second column, I'll be putting device names. Third column, I'll be putting IP addresses and so on. Right? Third, comma R1, comma 1.0.0.1, let's say. Then second entry is switch, comma S1. Okay. So first row is this, second row, third row, they're all like, you can have any number of rows, which is like your data rows. This is the columns, column row, these are the data rows. Save it, and let's open it in, okay, I can't put it on the Windows, right? So let me create it on Windows so that I can show you. Yes. Okay. So I can open with text editors. So it looks like this column, comma this, whatever we have put basically. But another thing that CSV supports is we can open with Excel. It looks like this. But this is not an Excel file, it is still a CSV file, it's a plain text file. Now I can take this same data. I can use some online converters to convert this into JSON to see how it looks. Okay. This is how JSON looks, right? In this, the square brackets denotes. What does square bracket denote in Python? List, right? So a list of, what is this? What does this denote? Dictionary, right? A list of dictionaries. Here we have multiple rows, 2 rows. So we have 2 dictionaries, right? One dictionary corresponds we call this as, I mean, this looks like Python dictionary, but we call this as JSON object, right? JSON object. So one JSON object corresponding to each row, right? This is the first row, this is the second row. But then what happened to the top row? Now top row is like column names, attributes. So it has converted the column, the top row attributes into keys. The row values are made as values. So this is key value. So it has converted this CSV into key value pairs with the first row as keys, the second row, third row onwards as data, the values. Since we have multiple rows, it has created a list. Okay, this is how JSON looks, but again, I can take this and save it. Data.json. So again, I can use my text editors. So because it's basically a text file. Now the third format is JSON to or CSV to YAML. YAML. This is how YAML looks. Again, these hyphens indicate list in YAML style. They don't use square brackets or curly braces. They just use these hyphens to denote list. Hyphen till wherever the next hyphen starts, that is one item. The next hyphen is second item. And you see the columns are here keys and the rows are values. Column and rows separated by colon, just like JSON, right? So this is supposed to be simpler and easier to read compared to JSON. There are people who differ with that, they don't agree, but somehow this has become a de facto standard for writing your other configuration files in networking and DevOps world. Okay, these are kind of, and the fourth one you have is plain text file. They are often mistaken as languages, but they are just data interchange. We call them as data interchange formats. Same with XML. XML stands for extended markup language. It's not a language as such. It's just a format, file format. Same way YAML, which was born from XML because we had HTML. Web pages are described as hypertext markup language, HTML, from which XML was born, extended markup language. Then someone came up with this YAML, someone came up with JSON, JavaScript object notation. Then someone else thought, okay, we need another this thing because JSON is too complex. So they thought, okay, we'll say, since we already have XML, we'll call it as, we'll say another markup language. So they initially named it as yet another markup language, YAML. Then they realized XML itself is not a language, it's just data interchange format. So then they renamed YAML as YAML ain't, YAML, Y for YAML, A for ain't, ML, markup language. Finally, they junked everything and they said YAML doesn't have any expansion. YAML is YAML, right? Why you don't try to expand it? So that's how this thing is born. I mean, these are crazy. Now, there is some guy who felt YAML is also quite complex. He came up with his own format, right? I'm sure you must have heard about it, called TOML. TOML is a file format for configuration files. It is intended to be easy to read and write, and due to obvious semantics, which aim to be minimal, and so on, so on. So that's how the world is changing. TOML, it stands for, what does it stand for? Tom's obvious. So some guy called Tom, he created Tom's obvious minimal language. Yes, we should come up with our own format. But the problem is, yeah, anyway. Okay, so making our life complex to simplify their lives. So this looks like that. So yet another format to get used to. Yes. Political and international problems. Okay. So that's what we'll be seeing. We'll take a normal, we already have this text file, right? So we'll take this data, put in our data.txt. Then txt .py. Right. Now in Python, the file operations, to be able to perform any file operations, first we have to open the file. Right? That opening the file can be done using open, and then just passing the path. Right? Path is, I'm in the current directory itself, so I don't need to specify. I can directly specify file data.txt. We'll start with this. Now, when you say open this file, what you get back is a file handle. You get a handle to that file, using which you can start reading the data from it. Right? So we can store that file in a variable. Text file is equal to open data.txt. Then you can start reading the data. Text file dot read. And this will be the data which is there in the file. So which means you are getting the data back. So you have to do something with that, either store it a variable or print it out. So let's say we just want to print it out now. That's what I'm doing. Input file dot read. And data.txt. What happened to the data? I didn't copy. I copied from here, forgot to paste. Okay, it read the entire data from this. Let me close all these guys. It opened this file, read this entire content, and just dumped it. Right. Now I can start reading line by line as well. Instead of reading the entire data, I can say read line. So only first line is read. Then again read the next line. Let's call this and see what happens. What do you expect to happen? What if the Python file is in a different directory? You just have to put the complete path or relative path where your file can be found. And the ultimate objective is your Python should know where to locate your file. If it can locate it, it will just go there, open it, and then read the data. Okay, first read line, read the first line. Then again you call read line, it read the second line. So looks like it is remembering till where I read, from where I had to read. Right? So how it does is it puts a pointer. First, when I open the file, this pointer is placed at 1. Then I call read line, this line is read, pointer moved here. Again I said read line, this random is read, pointer is moved here. Okay, that's how it happens. Now let me show you something. Now I'll say read. I read first 2 lines. Then I'll say read. Okay. It read first 2 lines as using read line, and it read rest of the data as this thing. Now, after this, again, you try to do the same thing. First line is read, second line is read, rest of the data is read. Again, I'm trying to read. Right? There's nothing, it's blank, because it has already reached the end of the file. Okay? Now, if I want to read again, I'll have to take the pointer back to the top of this thing. And that can be done using something known as seek. Seek the data. Go back to the top. Seek 0, which means go to 0 position. From there, you start reading again. Right? So first line is read, second line is read, this entire thing is read. Then the seek is called, which put the pointer back to the top. So from there, it is read again. Okay. So that's what this seek does. It takes the pointer back to the top of the page. Okay. So reads the entire content and returns as one single string, and then read line reads one by one line by one line. And a more useful thing is read lines, right? Which will read all the lines within the file and return you a list of strings where each element of the list corresponds to one line of the file. Lines is equal to text file dot read lines. Now, if you print this lines, it will be a list. How do you get list elements? You use for loop, for line in lines. Print each line. Okay. After each line, this blank line is coming up because print is inserting one line, one blank line, and there's a blank line within the data itself. That's okay. We can just manipulate it whenever we want. Okay. Yeah. The problem with this is we are simply saying open file. It returns this handle. After this file is executed, this handle still will still be lying in memory as a file dangling handle. Right? Most of the times, this kind of files become target for hackers. They get into a system, look for file handles lying loose, and then they grab it and they take access of it and insert some malicious scripts into these files. So it's a good practice to close the, if you are opening something, after you are done with it, you're supposed to close it. Right? But as human beings, we tend to forget things. Yeah, we have opened it, we have done something with that, we have processed it, we forget to close it. So ideally we should close it by using this statement. Txt file dot close. I'm done reading with it. Close it now. Okay. After closing, if I try to again read it, it will say you are trying to read it from a closed file. IO operation is on a closed file, so it has properly closed the file. Okay. So whether it be it like, let's say if you are working with databases, if you open a database connection, we are supposed to close it. If you open a file, we are supposed to close it. Now, because we are human beings, we tend to forget things. Python has provided us a nice way of taking care of these things, called as, there's a keyword called as with keyword. So using this with keyword, the with keyword, what it does is it retains the context. Context means the environment or the surroundings in which we are trying to operate. Here we are trying to open a file. So that becomes the context. Opening the file, reading the data, that becomes the context. So it remembers the context. Once our code crosses this context and goes out of it, it sees that yes, your code execution is done. Now this file which is open can be safely closed. So automatically it closes. We don't have to explicitly close it. So we'll say with open data.txt as. Now in the previously when we called it open data.txt, it returned as a file handle. Same thing happens here. When we say with open data.txt, we get a file handle. Using the as keyword, we say, let's say input underscore file. This is the file handle. With open data.txt as input file. So this ensures that the file is open and it is returned in this file handle. Then we can do your normal operations. Input file dot read. Then store it in a data. Okay. So internally, I think there's a way to look at this. Open and close also. File status or something like that is there. You can check, but you can be assured that this with will take care of closing the file. That was about reading data from files, but then we also should know how to write the data to files, right? Now, for writing the files, right? I mean, for any operation, normally what you do, right? This file is lying on the desktop. So you open the file and then either read the data or put the data into it, right? But the way Python works is not like us human beings, just open the file and do whatever you want. To Python, we have to specifically tell whether I'm opening the file for reading or for writing or for appending to existing text, right? If I so I'll have to explicitly tell Python what is the operation I intend to perform. But then you might ask me, you have not specified my intention here, right? That's because the way open function is defined. By now we know if something is missed, right? If some parameter is missed, that is set as, what is it set as? And the function is called. It is set as default parameter, right? So there is a guy hidden here called as mode. We are saying open this file. In which mode to open? So the default mode is read. Default mode to open the file is read. So since I was opening the files for reading, and I know that default mode of opening files is read, I can safely skip this. But for writing files, this will not work. You have to explicitly say, yes, I'm going to open this file for writing. So I'll say open data.txt, comma, write mode. As now I'm opening this file for writing, so I'll call it as output file. This is just name, right? It doesn't matter. But to make more logical sense, I would like to call it this way. Output file dot write some data. Okay, now my previous data is gone. It has become some data. And this is my original data. If I execute this code, you see that data is getting overwritten with some data. This is happening because I'm opening my file in write mode, which means it will overwrite the data. Okay, but say I don't want the data to be overwritten. I want the data to be appended to already existing data. How did I undo? Control Z. So I'll open in append mode. A. Let's open this file and some data. Of course, I'm not writing the new line. That's why it keeps getting appended. This thing. Okay. So these are the modes. R for read. W for write. It overwrites. X for exclusive creation, right? W assumes if you open a file in W mode, if the file does not exist, it will create. But if you say X, it's like if the file already exists, it will throw an error. I mean, W, if the file does not exist, it will create the file and then write it. If the file exists, it will simply overwrite the data. But with X, right, every time it tries to create a file, if the file already exists, it says file already exists. A for appending, T is like text mode, like this is like default again. B, if you want to, let's say, read the data in binary format, then we can use we can say B mode. Why would we want to read the data in binary format is reading in binary format is very fast, right? But let's say we want to open a file, read the binary content and write it to a different file. Read the content and write it to a different file. We don't intend to process the data as strings. In such cases, reading data as binary format will be very fast. File operations with the binary content will be very fast. Right? Plus is it helps you to open in multiple modes. If you say A plus, it is like it opens, file is open for reading, writing, appending, everything. Right? So if you intend to perform multiple operations, you open with A plus. Okay. We'll quickly see CSV and public close. So what is the first thing that we need to read CSV files? Of course, we need the CSV file. Other than that, need CSV. And we don't know what all is there in CSV. So safely for now, we can import CSV. Once we are familiar with what exactly is in CSV package, what do we need, what we don't need, then we can start importing only the things which are required. Like from CSV, import this, that. Okay, then we have to open the file as usual. Hit open data.csv. Others do not hesitate to stop me at any point of time and please ask any questions. Ask input _file. Right now, this is a special format, right? CSV format. So first we have to get something known as CSV reader, right? Reader is equal to CSV dot we have to call something called as reader and pass this file handle to that. And CSV dot reader of input file. We need to pass the file handle to the reader then. What we got, a reader object, right? Reader object which represents this data. Now from this, how we can get data is, you see these are like rows, right? So this reader object will be like collection of rows. So it is like a special kind of a list. So I think we can convert it into a list by wrapping it in a list. Let's try it out. Yeah, we can. So you see, each row is stored as a list. Each row of your CSV is a list. Then I wrapped it in another bigger list. So you have this list of lists. The other way I can do is, I know that this is a list, so I'll say for row, right? CSV consists of rows, right? For row in data, print row. First row, second row, third row. Now I know that, yeah, this is a list, so I can break each row, go inside using my list functions and extract the data. While this is fine, right? It would be better if I can get this data somehow in the form of a dictionary, right? So you see this here, I lost the connection between my header row and the remaining rows. Right? This is like very valuable information is lost. Now these are like three different lists. I don't know whether this corresponds to this or not, because that association is gone. So if I can somehow retain this association, it would be good. And so for this, CSV has given a special reader, right? Instead of a normal reader, we can call a special reader called as dictionary reader, DICT reader. Okay. So let me comment this guy for a minute. Copy, comment. Okay, instead of normal reader, I will call DICT. Let's see what happens. You see, now I get there are two rows, I get two dictionaries, and my association is maintained. Device type, router, device type, switch, device name, R1, device name, S1, IP, 10.0.0.1, 20.0.0.1. Okay, so these are the two reader options which are available. Obviously, DICT reader is of much use to us. Like that website which has done it, right? So if you wanted to do exactly that, we can just print list of data. So as we got list of dictionaries. But then why this guy is not printed? Because data has already been consumed. So say I'm trying to call this outside of this with block. So it is saying you're trying to perform your operation on a closed file. So that is the proof that yes, as soon as we cross this with block, the file is closed. But then how do you do it? Declare this variable outside. and then initialize it inside, then we'll be able to use it outside. Outside, and I will initialize this. You mean where I'm writing this code and running the code? Where I'm writing is, this is known as Visual Studio Code. This is a text editor. And just like how I've shown in the beginning of this, right? Visual Studio Code has some plugins, right? So as soon as it detected that I'm writing Python code, it prompted me, do you want to install a Python plugin? When I installed Python plugin, the Python plugin detected where is my Python installed on my system. It linked both, and it is giving me these options to run Python code straight out of my editor itself. And this is known as Visual Studio Code, which can be downloaded from Microsoft's website. And Python can be downloaded from Python website, installed, and then we can link them both and start writing code as well as executing right out of this. Okay, this I'll see how to retain it, but for now this is good enough. We can push it inside and then download. Okay, now same way, writing new data to file. CO5 CSV underscore write dot file. Right, we just have to take this guy. Instead of read, we just have to port CSV with open. Which mode should we open? A or A plus. A will open only for appending. A plus will also open it for reading. After updating, if you want to read the data and print it as a cross check, we can do that. So A plus can be opened as used as a default mode. Right. Now I intend to do all operations, so I'll simply call it as file or file. Okay, file is a keyword. I'll say file handle or CSV file. Okay, let's open this as CSV file. Now, writing data again can be done as a using a normal writer or DACT writer. There are two writers. If you're writing as a normal writer, right, it should be a list. And we also have to tell what is your column row, right? All that complication is there. So we can use DACT writer, where you just provide a dictionary, it will automatically be written. So we can take this guy. Store it in a new row. Euro is a dictionary. We'll modify, let's say, star1. Writer is equal to CSV file dot writer. We first have to get the writer. Then we have to say writer dot write. What to write? Euro. Okay. Let's see if it works. That is 04 itself. Has no attribute DSCT writer. Oh yeah, I didn't have to pass the handle, right? I have to tell. CSV dot DSCT writer and then oh yeah, what did I do? CSV dot CSV writer. I have to pass this. That is a field names. Why should I? Because I understand that a dictionary. No problem. This is a dictionary, right? So I'll say data is equal to new one. Fine. Let's start complicate things. Right header and right row. Right header and right row. So I can directly say right row. came here, firewall and W1. So I just need to figure out how to get it into a new lab. So these are my systems. So I don't have to explicitly define. I can get them from field names as equal to euro dot keys. This keys function, which will be this. Then I can use it. Okay, so that's how typing works. Right header can be used if you are creating a fresh file. There we also have to write this header followed by all the rows. I think there's one more. New line is equal to null or something like that. New line, new is fine. New line. New line is equal to null. Oh, I think this is. While opening itself, it should be mentioned, not while talking. Anyway, our objective is, I don't think is here about. Yes, A plus also will do. A plus we have already given. So relational data. No. So to introduce a one, which means we have to. Okay, I'll figure it out how to get to the first step. Okay, so that's about reading and writing text files and reading and writing CSV files. Any questions? Otherwise, we'll wind up. what A plus will do here is it'll open the file for appending data